Hello everyone, welcome to ChemHive. Today we are going to learn how to calculate the number of moles, mole fraction and mass fraction. Our first example is a gas mixture contains 40 pounds of oxygen, 25 pounds of SO2 and 30 pounds of SO3. What are the mass fraction and mole fraction? From the question, we know that our oxygen is 40 pounds. SO2 is 25 pounds and SO3 is 30 pounds. These are the mass of each component in a mixture. This is a mixture and it contains oxygen, SO2 and SO3. This is a mixture. So now we are asked to find the mass fraction and the mole fraction. To find the mass fraction of a component, it is the mass of one component, which is oxygen, divided by the total mass of the mixture. Total mass of the mixture, all of this. Total mass of the mixture. Now, the total mass of this mixture, when we sum up all this, is 95 pounds. So this is our total mass. Now, to get the mass fraction for oxygen, the mass of oxygen here is 40 divided by the total mass of it, which is 95. At the end of the day, the mass fraction for oxygen is 0.421. The mass fraction for SO2, using the same formula, but this time we are using the mass of SO2, which is 25, divided by the total, 95, is equal to 0.263. To calculate the mass fraction for SO3, still the same formula, but this time we are using the mass of SO3, which is 30, divided by the total mass, 95, which is equal to 0.316. At the end of the day, the sum of our mass fraction for oxygen plus mass fraction for SO2 plus mass fraction of SO3 must be equal to 1. We can sum this up and see if we get 1. So this is how to calculate the mass fraction of a mixture. To calculate the mole fraction, this is the formula for the component, is the number of moles of any component over the number of moles, total number of moles of the mixture. Now, from this question, we know that we're given in mass, not mole. We're all given in mass, not mole. So we have to first calculate the number of moles for oxygen, SO2 and SO3. How do we calculate the number of moles? To calculate the number of moles of a component is the mass over the molecular weight. The mass over the molecular weight. And from the question, the molecular weight for oxygen is 32. Molecular weight for SO2 is 64. Molecular weight of SO3 is 8. All we need to do is to substitute the mass here for oxygen divided by the molecular weight. At the end of the day, we get the number of moles for oxygen. The number of moles of oxygen is the mass, which is 40, divided by the molecular weight, 32. 1.25 pound mole. To get the number of moles for SO2 is mass, which is 25, divided by 64, is equals to 0.39 pound mole. 391 pound mole. To get the number of moles for SO3, do the same thing. 30 divided by the molecular weight, which is 80, equals to 0.375 pound mole. This is how we calculate the number of moles. We're able to calculate the number of moles for O2 as 1.25 pound mole. For number of moles of SO2 is going to be 0.391 pound mole. And number of moles for SO3 is 0.375 pound mole. Now we are asked to calculate the mole fraction. And remember I said, to calculate the mole fraction, we have to get the number of moles of the component, for example oxygen, divided by the total number of moles. So now we'll add up all this to get our N. Our total number of moles is, when we sum up all. So to get the mole fraction for O2, we have to put in the number of moles. Number of moles of oxygen is 1.25 divided by the total number of moles, 2.016. The other day we get 0.620. To get the mole fraction for SO2, the number of moles of SO2 is 0.391 divided by the total, 2.016. At the end of the day, you'll be getting 0.194. For SO3, the mole fraction is equals to the number of moles of SO3, 0.375, divided by the total, 0.186. These are the mole fraction for each of these components using this formula. When we sum up this, and this, the mole fraction must be equal to 1.00.